So far, we've let EF-Core generate all of the SQL for us. This module will focus on leveraging EF-Core's ability to execute raw SQL and stored procedures, as well as map to database views so you can easily query your read-only data. EF-Core does support working directly with a variety of database objects beyond just tables, as well as SQL statements that you can pass in directly. You can work with stored procedures and database views. You can map scalar functions, and thanks to yet another contribution from community member Paul Middleton, you can even map to table value functions. I won't be demonstrating mapping to scalar functions or TVFs, but I will leave a link to the documentation in the resources. There's another cool feature, which is also a little advanced for this Getting Started course. In the DB context, you can map an entity to a database query so that EF-Core will always use that query instead of generating its own SQL. There'll be a link in the resources for this feature as well. And for those of you who've been using EF since the days of yore, that is, before EF-Core, you may be happy to know that as of EF-Core 7, we are again able to map entities to stored procedures. I will definitely be showing you how this works. You'll learn about using EF-Core's ability to run queries using raw SQL or stored procedures, and still be able to capture the results into entities and track their state. You'll also learn how to use customized migrations to add stored procedures and views or any other database objects you need in the database. And you'll learn about using EF-Core's keyless entities, which are read-only, and how we can use those to capture results when querying the database view that we created. And finally, we'll look at another way of executing raw SQL, which is to execute non-query commands on the database. And as an example, we'll use a stored procedure to easily delete database rows, something I've mentioned a few times already. So let's get started. EF-Core lets you execute raw SQL for your queries in cases where you don't want to rely on EF-Core to generate those queries for you. And you have the option of providing the whole query in your SQL or using it to call stored procedures. There are two methods that let you execute raw SQL queries against your defined DB sets. One of the methods is called from SQL, and the other is from SQL raw. And the reason we have two methods is because of the difference between how EF-Core handles strings that are created in different manners. The last few versions of EF-Core also brought back a capability that we hadn't seen since EF6, which is the ability to query for types that are not entities. And those can be scalars or classes. This is possible with the database SQL query methods. I'll start by digging into the DB set methods, and then I'll show you around SQL query. Interpolated strings are required for the from SQL method and also for the database SQL query method. I've already been using interpolated strings throughout the demos. These are strings where you can integrate variables into a string without having to concatenate the string and the variables. With C#, that means you need a $sign in front of the string, and then the variables are wrapped in curly braces within the string. You can use from SQL with interpolated strings for straight SQL queries or to execute stored procedures. From SQL and from SQL raw are DB set methods, so they give you more ways to retrieve entities where you can use existing assets in your database or create procedures in the database when you have a query to express that's just too complicated for a LINQ query, or perhaps LINQ is just creating a badly performing expression. It's important when using from SQL raw to use parameters when doing things like filtering, so you don't have to worry about SQL injection attacks. For the first example, I'm using the context and authors DB set, and then appending from SQL raw to that. And I'm passing in the most basic of SQL, select star from authors. And don't forget a LINQ execution method. I'm using two lists at the end of this. Now that exact SQL will get sent to the database. And there are my authors that were returned to the database and materialized by EF-Core. And EF-Core will track these as well, just like with any LINQ query. One of the requirements with using the from SQL methods on the DB set is that the SQL needs to return data whose structure matches the entity represented by the DB set. That means your query needs to return all of the scalar properties. no less, and no more. So if MySQL only selected, for example, the name column, EF Core will throw an exception at runtime when it's trying to materialize author objects from the results. Additionally, because these are dbSet methods, they can only be used for known entities. You can't use the dbSet query methods to return a type that's not known by the DB context model. That also lines up with its ability to track whatever's returned. And keep in mind that if you are specifying the columns instead of doing select star, the SQL has to reflect the columns in the table, not the entity. So navigation properties like books, or if you're querying covers, then the author navigation property will also cause an exception to be thrown when EF Core tries to create those objects. You can append other link methods as well as some of the dbSet iQueryable extension methods. For example, here I've appended include to also bring back the books for those authors. EF Core is able to bring back the books along with the authors. It's really easy if you can express the entire query in a single string. But what if you need to compose a string from various expressions? How you do that impacts the security of the SQL you're sending to the database. So I think it's important to take a little time to be sure you're aware of the various paths and what their effect is. But right up front, I want to make sure you know that the golden rule for sending raw SQL is to never create strings with parameters embedded directly in them. That's how somebody with bad intentions can get SQL injection attacks passed through to the database. And you definitely want EF Core to send parameterized queries. You'll find a link in the resources at the end of this module if you want to learn more about SQL injection attacks. I also think it's important, before I dive into these queries, to make sure you're familiar with the different ways you can build up your strings, so that when I do show you the variations in SQL strings, you'll understand what I'm referring to. I'll start with a typical way of combining strings and expressions using concatenation. In other words, just adding the info together. I've got a variable, name, with the value Josie, and then I'm combining a string, happy birthday, with a variable, and the result is happy birthday Josie. Formatted strings contain numeric placeholders, and the placeholders are surrounded by curly braces. Then, after the string, you just list the data, other strings or expressions that result in strings. The formatted string knows to cast the int to a string when it's building up the result. And so we have happy 6th birthday Josie. And yeah, I'd have to add a bit of additional logic to turn those numbers into adjectives like third and fifth. Finally, we come to interpolated strings. And interpolated strings just squish down the formatted string. So instead of having placeholders and then following that up with the actual values or expressions that go in there, we put those expressions directly into the curly braces. You do have to preface the entire string, and that's before the quote sign, with a $sign. That's a signal to C# that this is an interpolated string. So now we can look at expressing raw queries with EF Core that have parameters using these various ways and seeing the cause and effect. Because it's so easy to accidentally send unsafe SQL, I'm going to show you a variety of queries and how they work out. And notice that I've named these methods safe and unsafe, so you can refer to this code later. Safe queries will send parameterized commands. The unsafe methods will not parameterize the queries and thereby allow SQL injection attacks through. First are some queries using from SQL raw, the method we already looked at. Any SQL that you build with concatenation will be unsafe because it will always put the parameters directly in the SQL. So that's an easy rule. Don't ever use concatenation for parameters with raw SQL. Formatted strings will not work. Well, they'll work, but they will be unsafe if you build them in advance. Here's an example where I'm using the string format command to express a formatted string. But the string format command will return a string, and that string will have the parameters embedded. So the variable is now just a plain string, and when I pass that into from SQL raw, again, we've got an unsafe query. But if you put the formatted string directly into the from raw SQL method, And note that I'm not using the string format command. That was the problem. That's what will turn it into a string. But if you just pass all the parameters for a formatted string, then the from SQL raw method knows what to do, and the resulting command will be parameterized and safe. Before I go further, I do want to point out something that I'm using in these queries that you may not have seen before. At least I know I haven't shown it to you. I'm using a method called tagWith in the query. tagWith will add commented text to your commands. The comments will show up in your logs, in your profilers, or wherever you're looking at that. And because I've got so many different methods and queries here, I wanted to make sure that reading the logs, it made it clear which queries I was sending in. Now we'll finally take a look at using interpolated strings. In this method, I am using an interpolated string, but I'm still using the from SQL raw method. And again, I'm pre-creating that string in the SQL variable. And so it gets pre-processed, and the variable that I'm passing in is now a plain old string, and the parameter is embedded directly into it. The compiler doesn't care about this, and the command that it sends to the database won't be parameterized, and bam, there's the possibility of another SQL injection attack. See why logging or profiling your database is so important? Remember, the formatted string worked as a parameter of from SQL raw. What about the interpolated string? Nope, it's still unsafe. From SQL raw doesn't know how to create parameterized queries from interpolated strings. It knows how to do it from formatted strings, but not interpolated. So it looks like you're doing the right thing, but again, this is unsafe and will allow an injection attack through. So finally, let's use an interpolated string with the from SQL method. Passing my interpolated string directly in as the parameter of that method finally results in a parameterized query, which is safe. And this is why we have to have a second method. There was no way for one method to be able to handle all the different variations here. There are two more things I want you to be aware of about the from SQL method where the compiler will catch two problems for you. The method accepts one and only one parameter, and it can't be a string. It has to be a format string. Let's see what that looks like. What if you pre-create the interpolated string? Well, again, the resulting variable is now just a plain old string. But it's still safe. It's so safe because the from SQL method won't take a string as a parameter. So it won't even compile. It complains that it wants a formatable string. But wait a minute, if it wants a formatable string, why not just pass in the other formatable string expression? Nope, that won't work because the method only takes one parameter, and the formatable string expression has multiple parameters, so this won't even compile either. Well, that was a lot of introspection into using raw SQL and EF Core with parameters. But it's so important to be sure that if you're passing in raw SQL, you don't lose the security that EF Core can give you with parameterized commands. And in the end, there were really only two safe and compilable ways that I showed you, but I think it was really important to understand those other syntaxes where you would be creating unsafe SQL. And it was also nice to know about syntax that wouldn't even compile. Unfortunately, IntelliSense and the compiler could lead you astray here, and that happens a lot when developers want to just use their tools without learning how they work. But you're here taking this course and you're learning, and that makes me so happy. And hopefully you've also got someone on your team who's got your back and can check to make sure you're not accidentally allowing injection attacks through as you're growing your skills.